So good morning students, welcome back to chemistry online class. So in the previous section we have seen about aldol condensation reaction. So in this section we are going to see about Cannizaro reaction. So listen carefully. So today's class we are going to see about Cannizaro reaction. So to carry out this Cannizaro reaction, certain conditions are given. So first condition we are choosing aldehyde as an example. So in this aldehyde which do not contain alpha hydrogen atom. So aldehyde as an example which do not contain alpha hydrogen atom. So here we are using aromatic aldehyde as an example. So this aromatic aldehyde does not contain alpha hydrogen atom. Does not contain alpha hydrogen atom. So this is an first condition. So we are choosing benzaldehyde as an example. So the formula for benzaldehyde is C6H5CHO, or we can write like this also, benzene ring with CHO. So this is an formula for benzaldehyde. So by using this benzaldehyde only, we are going to carry out Cannizaro reaction. Then second condition number 2. Second condition, the reaction will be occurs in presence of alcoholic or aqueous solution. So reaction occurs in presence of alcoholic or aqueous solution. So here we are using aqueous sodium hydroxide as an example. Reagent. So the Cannizaro reaction occurs in presence of either alcoholic or aqueous solution. Here we are using sodium hydroxide as an example. 50% sodium hydroxide. So this 50% is nothing but 50 gram of sodium hydroxide dissolved in per 100 gram of solution. So here we are choosing the reagent, or in presence of sodium hydroxide only the reaction will be occurs. So 50% sodium hydroxide we are choosing. So 50% is nothing but 50 gram of sodium hydroxide dissolved per 100 gram of solution. This is one second condition. Then third condition number 3. So we are using 2 molecules or 2 moles of aldehyde. Already we said 2 molecules of aldehyde. Here we are choosing benzaldehyde as an example. Benzaldehyde. So in this benzaldehyde, at a time both oxidation and reduction takes place. At a time both oxidation and reduction takes place. Both oxidation and reduction takes place. This reaction is called as an disproportion reaction or disproportionation reaction. So what is meant by disproportionation reaction? So when we are using 2 moles of aldehyde, at a time both the reaction occurs, both the oxidation and reduction takes place. This reaction is called as an disproportionation reaction. So I will give you one example for disproportionation reaction. So already we said we have selected benzaldehyde as an example, right? So I am going to write 2 moles or 2 molecules of benzaldehyde. So the formula for benzaldehyde is C6H5CHO 1 mole over plus C6H5CHO. So this is an starting material we used here will be an benzaldehyde. So the name of this compound is benzaldehyde, 2 molecules. Okay. Now this undergoes the reaction will be occurs in presence of aqueous 50 percentage 50 percentage sodium hydroxide. 50 percentage sodium hydroxide. What is our expected product? So we already said at a time both oxidation and reduction takes place. If oxidation occurs in benzaldehyde means our product is acid. So in this molecule, in this is an benzaldehyde, right? So in this molecule, if oxidation occurs means our expected product will be an acid. So if oxidation occurs means our expected product is what? Acid. So the product is C6H5 bond C double bond OH. So when oxidation occurs means our expected product is what? Acid. So the name of this product is what? Benzoic acid. Now, if in case reduction occurs means, so this is an oxidation. If in case a reduction occurs means our product is alcohol. So the formula for alcohol is C6H5CH2OH. When reduction takes place, that's why we already said at a time both oxidation and reduction takes place. This reaction is called as an disproportionation reaction. So when oxidation undergoes means we will get the product as acid. When reduction occurs means our product is what? Alcohol. So the name of this compound is benzoic acid. The name of this compound is benzyl alcohol. Now, so this reaction is called as an what? Disproportionation reaction. Now this reaction, now we got from oxidation, we got one acid product. No. So this acid again reacts with this sodium or base. Sodium hydroxide together we are saying means it is one of the base. No. Sodium hydroxide. So this acid reacts with this base. Acid reacts with this base. Our expected product is C6H5COONA. So this reaction is also called as an acid-base reaction. So once again I will repeat, listen carefully. We are using 2 moles of an benzaldehyde. That's one of the condition. So we are using 2 moles of an benzaldehyde. At a time both oxidation and reduction takes place. If oxidation takes place means what is our expected product? Acid. Reduction takes place means our product is what? Alcohol. Benzyl alcohol, benzoic acid. Now this oxidation from by oxidation we got one product. No, again it undergoes or it reacts with base sodium hydroxide. We will get the product as what? C6H5COONA. So the product is nothing but sodium benzoate. So I will write this side, I will write the final product. So our final product is from oxidation, our final product is sodium benzoate, C6H5COONA. So the name of this compound is sodium benzoate plus C6H5CH2OH. So what is the name of this compound? Benzyl alcohol. Benzyl alcohol. So this reaction is called as an disproportionation reaction or acid-base reaction. So these are the conditions we have to use to carry out which mechanism? Cannizaro mechanism. So once again, listen carefully. So Cannizaro reaction will be carried out by using aldehyde as an example. So in this aldehyde which do not contain alpha hydrogen atom, a best example for Cannizaro reaction is aromatic aldehyde. So here we are using benzaldehyde as an example. So in benzaldehyde it does not contain alpha hydrogen atom. So the formula for benzaldehyde is C6H5CHO or benzene ring with CHO. So first condition over. Then second condition, reaction occurs in presence of either alcoholic solution or aqueous solution. So here Cannizaro mechanism, here we are using aqueous sodium hydroxide 50 percentage. So 50 percentage is nothing but 50 gram of sodium hydroxide is dissolved per 100 gram of solution. Then third condition, we are using 2 moles of aldehyde. So in that at a time both oxidation and reduction takes place. This reaction is called as an what? Disproportionation reaction. So one of the example I have given here, 2 moles of benzaldehyde. This one. So when undergoes oxidation means our product is what? Acid. COOH as acid product. But when it undergoes reduction means our product is what? Alcohol. Benzoic acid, benzyl alcohol. Right? Now this acid product again it reacts with base, sodium hydroxide base, and we will get the product as what? Sodium benzoate. Sodium benzoate. So this reaction is also called as an acid base reaction. So next we are going to carry out the mechanism, Cannizaro mechanism. So mechanism. So this Cannizaro mechanism occurs by 3 steps. But in aldol condensation reaction, we carry out the mechanism by using how many steps? 4 steps, right? Here we are using the mechanism will be occurs by using 3 steps. So first step is attack of OH minus ion on the carbonyl carbon. So what is the first step? Mechanism will be occurs by 3 steps. So first step is attack of OH minus ion on the carbonyl carbon. Then second step, hydride ion transfer takes place. Transfer of hydride ion or hydride ion transfer will takes place in the second step. Then third step, acid base reaction occurs. Acid base reaction. So these are the 3 steps to carry out Cannizaro mechanism. So what is the first step? Attack of OH minus ion on the carbonyl carbon. Second step, transfer of hydride ion from one carbon to another. Then third step, acid base reaction. Now we are going to see one by one. So step 1. So you know very well in the introduction part itself I told you we are choosing benzaldehyde as an example, right? So you know the formula also. So what is the formula for benzaldehyde? C6H5CHO. So you see the formula. So what is the formula? C6H5CHO or benzene ring with CHO. Now, for our convenient purpose, listen carefully. So, our example is benzaldehyde. So, our example benzaldehyde. So, you know the formula C6H5CHO. So, just for our convenient purpose, we are writing this of benzaldehyde as like this. C6H5 bond C double bond OH. So listen carefully. So we have selected benzaldehyde as an example. In this benzaldehyde, it does not contain alpha hydrogen atom, right? So we have written this benzaldehyde structure C6H5 bond C double bond O single bond H. Now what's the first step mechanism of first step will be an attack of OH minus ion on the carbonyl carbon. Now benzaldehyde ready. Benzaldehyde we have written benzaldehyde structure plus OH minus base attack will takes place in where? In carbonyl carbon. In carbonyl carbon. So OH minus attack will take place in this position. So this position is called as an carbonyl carbon position. Now shall we write the product? Very simple mechanism, very simple. You just write like this. Now the same time this OH minus will attack here. No, now this bond, double bond will shift here. Now O becomes O minus. This bond will change as minus. Now our product is C6H5 bond C single bond. This one of the bond from here it becomes O minus bond H. This OH minus attacks here in this carbonyl carbon. So now here it becomes bond OH. So this is an first step product. So what is the first step? Attack of OH minus ion on the carbonyl carbon. So attack OH minus attack occurs where? In this carbonyl carbon here. Now this bond will shift here. This bond becomes what? O minus. So this is a first step. First step over. Step 1 over. Then we can see step 2. Now you read the step 2. Hydride ion transfer. Transfer of hydride ion takes place from one carbon to another. I will explain. You just write this product here. Here you write this step 1. From step 1 we got one product. No, you write this product here. Now what's the product? C6H5 single bond C single bond O minus single bond H single bond OH. So in the second step we are using another mole of benzaldehyde. First step we used 1 mole of benzaldehyde. That's a rule. We can use 2 moles of benzaldehyde, aldehyde. Now first step, in the first step we used 1 mole or 1 molecule of benzaldehyde. In the second step we are using another mole of benzaldehyde. So we can write the structure C6H5 C double bond OH. So from where this product we got? From where? This is a product from step 1 product. That only we have written here. Same product plus another molecule of benzaldehyde. So now these two reacts. What is the step 2? Transfer of hydride ion. Hydride ion transfer will takes place. Now you see what happens here. Now listen carefully. So our this is the product from step 1. We got this product. It reacts with another molecule of benzaldehyde. Hydride ion transfer will take place. Hydrogen ion means representation H plus. Listen here. Hydrogen ion. Hydrogen ion means representation what? H plus. Hydride ion means H minus. Hydride means H minus. So listen carefully. Step 2, attack transfer of hydride ion. Transfer of hydride ion. So now we have written the step 2 products. From step 1 we got one product that we have written here. 1 mole, another mole of benzaldehyde we have written here, right? Now here you see this bond will shift. So this bond will shift here. Now this hydrogen becomes H minus. Now this hydrogen becomes what? H minus. So this H minus is called as an what? Hydride ion. Now this hydride ion will shift here. So this hydride ion will transfer from one carbon center to another carbon center. Now you see, so now this hydrogen will comes here. Now you check carbon valency. This will totally, this hydrogen will comes here. No, hydride in the form of hydride. It will comes here in this position, right? Now you check the valency for carbon 1, 2, 3. So to satisfy the valency of carbon, we are shifting this negative charge O minus as bond. Now while writing the product here, now here it becomes what? Double bond O. The same time you check it, this hydride ion will comes here. Now the carbon balance becomes 5. To satisfy that, we are shifting this bond here. Now the here becomes what? O minus. Clear? Shall I write the product? So listen carefully. So see, first product is like this. C6H5 single bond C, single bond C. This minus becomes one bond. Already one single bond is there. Now this minus becomes shift here, means we will get one more bond. So C double bond O, single bond OH. So this part over. This hydrogen get converted into hydride and shift this hydride here. Plus another product. You write this product also. C6H5 single bond C O minus single bond H plus this hydride will comes here, no, bond H. So this is an second step product. So from this second step we got one acid, benzoic acid, then one intermediate product also we got. Then step 3. So what is the step 3? In step 3, acid base reaction will be takes place. So in step 3, acid base reaction will takes place. To carry out a step 3, have to write the product from step 2. So we got 2 products now. From step 2, we got 2 products. You write this product here. So I am going to write, use, listen carefully. So see here, C6H5 single bond C double bond O OH plus C6H5 single bond C O minus bond H bond H. So this is an product we got from where? From step 2. Now what happens means, so you see here this OH is here, no, so this one is benzoic acid C6H5 COOH. So we can write this OH as like this. So we can write this OH as like this. Oxygen O bond H. So listen carefully. So we can write this OH as like this. O bond H. Now this hydrogen will transfer. This hydrogen will transfer from one oxygen to another oxygen. So listen carefully. In benzoic acid, OH is there. COOH. From this, from here, one hydrogen will transfer from one oxygen to another oxygen atom. Now what is our expected product? So here this OH will comes here. Now it becomes what? So our expected product from step 3 is C6H5 single bond C double bond O single bond O minus. This hydrogen will shift from one oxygen to another oxygen. Now plus what is the next product? C6H5 single bond C, here hydrogen H OH. So this hydrogen will shift here from one oxygen to another oxygen. So this is a step 3 product. So you see from step 2 we got 2 products. So we can write this structure as like this also, or we can write simply, we can write C6H5 C 2 hydrogen CH2OH. So we can write these structures like this also. C6H5 CH2OH. Now what is our final product? Benzoate product plus benzyl alcohol. So I will write separately. I will write this product from step 3. We got 2 products now. So I am going to write separately. So listen here. So what is the final product? Our final product is, one product is C6H5 C double bond O minus plus C6H5 CH2OH. So the product name is benzyl alcohol. Benzyl alcohol. So this product is benzoate. C6H5 COO minus benzoate. Now this benzoate product have tendency to react with base. Here we are using sodium hydroxide as a base. So now when this benzoate reacts with the base, means our expected product is C6H5 COONA. So the product name is sodium benzoate. Sodium benzoate. Now this reaction is called as an acid-base reaction. So this reaction is called as an what? Acid-base reaction. So these are the three steps used to carry out which mechanism? Cannizaro mechanism. So listen carefully. Once again I will explain the mechanism. So the mechanism will be occurs by so listen students once again. So the mechanism will be occurs by three steps. No. So first step attack of OH minus ion on the carbonyl carbon. Then second step hydride ion transfer. So hydride is nothing but H minus. You know very well, right? Then third step acid base reaction. Now you see first step one. You know that our rule is or our condition is we can use 2 moles of aldehyde. No, here we are using benzaldehyde as an example. So what's the formula? C6H5CHO. 6H5 single bond C, single bond H, double bond O plus it reacts with the OH minus attack takes place. Now this OH minus attack this carbonyl carbon position. Now our product is C6H5 single bond C, single bond H. Now this bond will shift here. Now it becomes what? O minus. This OH will attack here. Now the product is single bond OH. Now you write this product. From step 2 we got one. Step 1. From step 1 we got one product. No, you write this product here. Step 2. Same product only I have written here, right? Plus another molecule of benzaldehyde C6H5CHO. Now transfer of hydride ion takes place in step 2. Here, this bond will shift here means it becomes what? H minus. This H minus is called as an hydride ion. Now, this hydride ion will shift from one carbon to another carbon. Now you check the valency for carbon. It will shift here. No. Now you are checking means it becomes 3. We want to satisfy the valency with 4. That's why we are shifting this minus as bond. Now this minus becomes what? Bond. So the product is C6H5 C double bond O OH. Now this hydrogen will shift here. Now the product is what? C6H5 C this H. Now this hydrogen will comes here. Now it balance becomes 5. To satisfy the valence only again we are shifting this bond also here. Now it becomes what? O minus. Clear? Step 2. Now you see. Step 3. From step 2 we got two products. No, you write same product here. So you write this product here. Now you see OH. So we can write this OH as O single bond H. Now step 3, acid-base reaction will occur. First, this hydrogen will transfer from one oxygen to another oxygen. Now, here it becomes C6H5, C double bond O, single bond O, O minus benzoate product. Now, again, this hydrogen will shift here. No, so we will get the product, one more product as C6H5, C, single bond O. This H will comes here. H, single bond H. Or we can write this structure as like this. C6H5, CH2OH. So this reaction, now we got one benzoate product as well as one benzyl alcohol. I have written the product separately. Listen here. I have same product only I have written separately. So listen here. So this is an benzoate product. This one is what? Benzyl alcohol. So now this benzoate again reacts with base sodium hydroxide. We will get the product as what? Sodium benzoate. So this reaction is known as acid. This reaction is known as acid base sodium hydroxide base reaction. So this reaction is called as an what? Base this acid reaction. So these are the steps used to carry out which mechanism? Cannizaro mechanism. So very easy mechanism. You just learn this question, write and learn. So have you all understood? So thank you.